In this video, we're going to talk about solving one-step equations. You're going to take your notes in your interactive notebook, just on the next page, and you're going to title across the top, Solving One-Step Equations. We're going to start with some definitions. So again, if it's on my screen, it's important for you to write down. So anything that's here, you're going to also write in your notes. So our first definition is an equation. An equation shows that two quantities are equal. And an equation could be something as simple as 12 equals 3 times 4, because those two things are equal, or sometimes it'll have a variable in there. Okay? So an equation needs an equal sign, and we're just showing that two things are equal. Now, a solution of an equation is a value for the variable that makes the equation true. So let's take this equation that has a variable. Remember, 3x means 3 times x, so x equals 4 is a solution because 12 equals 3 times 4. That is a true statement. X equals 10 is not a solution because 12 does not equal 3 times 10. I'll use parentheses that time. So a solution just means that it makes it true. And again, these definitions are very important. Pause if you need to. I'm going to keep moving forward. What we're going to do next is talk about how to solve an equation. Now, one that's simple, like 12 equals 3x, probably most of you went 4 right away. And that's fine, but when we're solving our one-step equations, we're still going to show our work because we need to know how to do that for the more complicated ones. So while we're learning the simple ones, the ones that we can probably do in our head, we're going to be showing work so that we can make sure that as they get more complicated, we still know what to do. So, first of all, let's talk about how we solve an equation. To solve an equation, we perform inverse operations to isolate the variable on one side of the equation. So when I say isolate the variable, what I'm talking about is getting the variable by itself on one side. Now we're going to work through lots of examples there, but let's talk about this inverse operations first. So for our inverse operations, addition and subtraction are inverses. So if you are solving an equation that has addition, you're going to use subtraction to undo it. Okay? If you have an equation that has subtraction, you're going to use addition. They're inverses of one another. Okay? Next, we have multiplication and division. If you have an equation that has multiplication, you're going to use division to undo it. And if you have an equation that has division, you're going to use multiplication to undo it. So you're using the inverse. The way I think about it is as you cross that equal sign, you need to remember to be doing the inverse. Okay? Okay, pause here, rewind if you need to get those definitions written down. And then we're going to do 4 quick examples. Oh, actually, no, we're not. I forgot. We have to talk about our properties of equality because it's our properties of equality that actually allow us to do our solutions. So, the properties of equality can be used to justify the steps taken in solving an equation. So we want to be able to say, I did that because ... So there are 4 properties of equality. And this is quite a bit of writing, but it's important, so I do want you to write it down. So we're going to start with our addition property of equality. Our addition property of equality says you can add the same number, sorry, my screen is a little touchy today, here we go. So you can add the same number to both sides of an equation and the statement will still be true. So for example, if I have, well, let's just go super simple. 3 equals 3, which we all agree. if I add the same number to both sides, it stays true. That's all we're saying. Okay? So if 3 equals 3, then 3 plus 4 equals 3 plus 4. All I'm doing is adding 4 to both sides. Now, obviously, we're going to do this with equations with variables in it, but that concept is staying the same. Now, each of our 4 operations that we're talking about today, there are plenty of other inverse operations, but the 4 we're talking about today each have their own property. So our subtraction property of equality, you can subtract the same number from both sides of an equation, and the statement will still be true. And I'm going to actually write this one in algebra for us. Should have done that for the addition one as well. If A equals B, then A minus C equals A minus B minus C. So I can subtract the same thing from both sides and it stays true. Let's actually go back and do that for our addition one as well. I can do it without messing everything up. So if A equals B, then A plus C equals B plus C. That's our addition property of equality. Okay, I know I'm going a little fast. Pause it if you need to. We'll go on and look at our multiplication property of equality. You can probably guess what it says. You can multiply both sides of an equation by the same number and the statement will still be true. So in algebra, once again, if A equals B, then A times C equals B times C. I can multiply both sides of my equation by the same number and my statement will still be true. Okay, last one. Our division property of equality. So you can divide both sides of an equation by the same number other than 0 and the statement will still be true. So if A equals B and C does not equal 0, then A over C equals B over C. The reason C can't be 0 is because you can't divide by 0. It is not possible. Okay, so I know I went through that pretty fast. I'm going to show them all to you here, and you can pause and finish writing them down if you need to. And then we're going to work 4 quick examples. Okay, so here are our 4 examples that we are going to do, starting with this first one. So x minus 7 equals 13. If you want to take a second to write them all down, you can. Just pause it. And I'm going to go ahead and jump into this first one. Okay, so to start, we have x minus 7 equals 13. And again, I talk to myself when I'm solving, and I heard myself say minus, so I'm subtracting from my variable. The inverse operation of subtraction is addition, so I'm going to add 7 to both sides. Here's why I do that. Negative 7 plus 7 is 0. So on the left-hand side, I have x plus 0. I don't write the plus 0 because it's 0. And then equals 20. 13 plus 7 is 20. I can do a quick check. Plug my 20 in. Is 20 minus 7 equal to 13? Yes, it is. So I know I did it correctly. So for that one, I used my addition, hit the wrong thing, property of equality. Okay? Let's look at our second example here. I have 26 equals 8 plus v. Plus, we're adding. So to get rid of the addition, we want to subtract because they are inverses. But I need to do it to both sides of my equation because that's what my subtraction property of equality says that I need to do. When I do that, 8 minus 8 is 0. So over here I have 0 plus v, which is v, and then I have 26 minus 8, which is 18. And then again, I can do a quick little check. Is 26 equal to 8 plus 18? And the answer is yes. I had to do the addition real quick just to make sure I didn't make a mistake. Okay, so that's our addition property of equality and our subtraction property of equality. Let's go ahead and take a look at our last two examples. So, m over 4 equals negative 13. I didn't actually say an operation there, but I know a fraction is a division problem. So a fraction is a division problem. So since it's a division problem, to undo the division, I am going to multiply. So watch how I show this. I am going to multiply both sides by 4. Now on this side, what's happening? I'm multiplying by 4 over 1. So I get 4m over 4. The 4's cancel. 4 divided by 4 is 1m. And then negative 13 times 4 is going to be negative 52. And notice this is done. I'm isolated. I know I have that little 1 there, but it's a 1. I could just erase it if I wanted to, right? So 1m and m means the same thing. So m equals negative 52. I can do a quick check. Is negative 52 over 4 equal to negative 13? And when I do that quick division, yes it is. Okay, our last example that we're going to work through. I have 10n equals 40. Again, I didn't say an operation there, but anytime a number is right next to a variable like that, we know it's multiplication. So the inverse of multiplication is division. So I'm going to divide both sides by the 10. Remember, you're trying to get the variable by itself. So when you're deciding what you're going to divide by or add or subtract, it's always what's with your variable. Okay? So 10 divided by 10 is 1. So I get 1n, or just n. 40 over 10 is 4. So again, we can do our quick check. 10 times 4 equals 40, which is true. And I just realized I didn't put my justification here. So my justification, this is the division property of equality, and here this was the multiplication property of equality. Okay, so that is it for our one-step equations. Hopefully I didn't go too fast for you there. Make sure that you rewind and get all of those notes and all of those definitions because they're very important to us. And then we will move on to our multi-step ones once you've mastered these one-step ones.